My name is Oleg Bugry, and I am a senior scientist and a group leader at AgriVida Inc. My work is involved with development of vectors for plant transformation, as well as molecular characterization of transgenic plants in AgriVida's pipeline. I believe that my choice of career in science was largely influenced by my parents. I grew up in a family of agricultural scientists, and it was very common for me to hear many science-related conversations at home. My dad held a PhD in plant breeding, and my mom was a chemist. I also spent a lot of time during my childhood on either experimental plots pulling out weeds or in chemical laboratory observing how color of solutions would change during titration. There was really little doubt that working in science was going to be a lifelong commitment for me. I started with the same alma mater which my parents graduated from, and continued with a career in science. Every scientist, I do enjoy seeing successful outcome of my experiments, because it promotes advancement of the project to the next level or step, and oftentimes brings new opportunities in research. Altogether, it gives satisfaction with the work and provides feeling of rewarding. My work is always a part of a teamwork, and the team goals could be very ambitious, yet exciting and requiring innovation. I think that my desire to see overall teamwork progress plays a large role in my scientific contribution for innovation. Failure is an inevitable part of any scientific research. I believe that failure is advancing science because you are constantly putting forward new ideas and rejecting them based on real experimental data. Failure is not a bad thing, and it could be considered as a sort of motivator in research. But one certainly needs to accept failure in experimental work as an integral part of the entire process. With that said, my somewhat general approach to dealing with failure in my experimental work involves more brainstorming, perhaps with my colleagues, detailed planning and careful execution of experiments. At times it's a tedious approach and might require several attempts to yield desirable research outcome. But sometimes also failure could be indicative of a dead end in a project. And I do realize that this is a part of a normal scientific research process. Of course, it's difficult to predict where scientific progress will bring the agriculture in 50 years. Who could have thought 25 years ago that large genome sequencing data will be available for the majority of cultivated crops, and gene cloning would become a relatively easy procedure? I think that in 50 years, many high-tech solutions will be widely implemented in agricultural processes. Those include the use of computers, robotics, drones, various sensors for real-time monitoring situation in the field. It will allow growing crops in more efficient and environmentally friendly ways through precise and timely application of fertilizers, water, pesticides, and herbicides. Perhaps vertical farming will contribute in a large way to growing crops under those requirements. I also think that transgenic plants expressing not only input traits but also output traits will be in high demand.